Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. Every Tuesday, Arun and I present sessions for introducing beginners to Python. We've been doing this since 2018. We started off in doing it in person, but since COVID we've been doing it online. But we'll return to doing it back in person as soon as we can find a venue in Brisbane somewhere. Anyway, tonight's session we're going to look at how to use Python to create a game, and we're going to use the wordle game as our example. Wordle's a craze going around the world at the moment. New York Times has just bought the game from its original author. And so we'll just see how difficult it is for us to write the same game in Python. During the session, the point of these live sessions is that you can ask questions. So you can ask questions on YouTube chat, and I'll be following that. And also, most people will be asking questions on Slack. So if you follow on Slack, and that means I can answer it, or other people can answer it. If you're not on Slack, read the details below. You'll see how to get an invitation into our Slack group, and we'll be using the Learning to Code channel in Beginners Python. I see Sasith has sent a greetings, so greetings to Sasith. All right. Now tonight's session, I thought we were going to be using, we might have to use desktop Python, but we'll start off in Collab and see how we go. And I think I've split the project up into 2 sessions, so we'll do it this week, will be the first, and then in a month's time we'll do the second session, and that'll that's the part that'll definitely need to go to Python. So if you have Python installed on your computer, that'll be good for the second session. But for now, we can just go with Google Collab, and I provided a link to a notebook, and you can use this notebook as the basis of what we're going to do tonight. So click on the link. That link is both in the YouTube comments, and it's also in the Meetup description. That's good. So it was shared, and our objective today is writing a wordle game in Python. All right. Now, when you first get this Collab notebook, you won't be able to make changes to it, but there's a button here that says Copy to Drive, and that'll copy it to your own Google Drive, and that way you'll be able to make changes to it, you'll be able to run the exercises, and you'll be able to save the results. So I'll do it just like you're doing it. I'll make a copy because I'm in as a different user here than the user that created, which was also me. And you see now I've got the word copy of Meetup 137 at the front. So these Google Collab notebooks, they give us a full Python environment. They give us a little Unix machine, virtual machine that we can run some code in. So it's very generous of Google to give this to us for free. All we need is a Google account. The first thing is to get it running. So we'll click on connect, and that'll start it running and save us a bit of time later. Okay, and the other thing I'm going to do is I'll share this one, which will have all the things that I type in tonight. So I'll copy this link onto Slack and onto YouTube chat, and then anyone you can just put the link in and then just hit refresh throughout the session, and you'll get the changes as I type them. So there you go, I've pasted the link there. Marcus is asking, is there any machine learning involved with this Wordle project series? Probably not. I was thinking of doing a third session on Wordle, which maybe looked at optimizing the choice of words and getting the computer to play Wordle. But we'll see how we go. But Arun is the real expert on machine learning, and he'll be doing the sessions from the next 3 sessions starting next week. All right. So to use Google Colab, it's a notebook here is a bunch of cells, and these cells can contain text or they can contain code. So this is an example of a text cell in the rectangle, and this is an example of a code cell. So when you get to the code cells, you'll have a play button on them, which you can click the play, or you can do the keyboard equivalent, which is Control Enter. So if I click play, now the reason I've put these 2 lines of Python code at the beginning is I want to see what version of Python Google Colab is running, and it's currently 3.7.12, and that's some of the lines of code that I need for the following session to this one require 3.8 at the earliest, so that's why we'll have to use desktop Python for that. But in the meantime, we'll just keep going along with Google Colab because it's great for everyone to see how it runs step by step, and everyone can run on their machines even if they don't have a Python installed. Okay, so the game that we're trying to write is this New York Times wordle game. So it's like a cross between Scrabble and Mastermind, if any of you remember those things. You got to guess the wordle in 6 tries. On each try you have to you put in a word, has to be a word, and you get a response saying whether the letters in that word are in the right place. So in this case the W is the right letter in the right place, or they're the right letter but they're in the wrong place. So in this case I is a letter that's in the word but in the wrong spot. And all the other letters will just be stayed the same. So U is an example of a letter that is not in any word in any spot. Okay, so that's how it goes, and you get 6 goes of each of these 5-letter words. Alright, so that's what we're going to write, a program that will run that. So let's start. I'm going to create a couple of variables here. I'm going to say the answer is going to be brace. So that's the word we're going to try to guess. And our first guess is going to be realm. So challenge 1, given an answer and a guess, display which letters are in the right place. Okay, so think about how you would tackle this problem. And I've left a blank cell here for you to write some code. Now I'm going to write some code and describe to you how I'm thinking. What I think I'll do is I want to loop through each letter of guess and see if it's in the right place in the answer, and if not, I just want to see if it's somewhere else in the answer. All right, and we're going to do this. Yeah, let's try that. So I'm going to have a variable I, which is going to be my index as I work through the letters of the word. And so if I want it to go, I to go up in value starting from 0, then I'll use the range function, and that'll take me from 0 up to the length of the guess, which is 5. And it will always be 5, but I guess if we do it this way, then we might change the word to be a 6-letter guessing game later. And in fact, we'll do it on the answer because the answer is specifying which one of the words is going to define how many letters there are. Okay, so we're going to get a letter for the answer is going to be, we can use the index on that letter. We use square brackets to refer to the index, which is the position within that word, and letter guess equals the guess. Now, one thing that I've done a mistake already. I should have run this cell first before I try to run this cell down here. So I've run it, and I can tell that it's run now because it's got a number 2 in there. You'll see this one we didn't run because it's just blank, but because it's only got comments in there, we don't need to run it at all. Alright, now let's check if those two are the same. If LA equals LG, then we'll print, we'll just say, position I, the guess, letter guess, and we'll say is in the correct place. Otherwise, we want to check if it's maybe somewhere in the word. So we'll use else if, and we put in our condition, and that is letter guess in the answer. We know it's not in position I, but it could be somewhere else in the answer. Is in the wrong place. And if it's not in either of those, then it's just the wrong letter. Is not in the answer. Okay, so let's try running that. And we get R is in the wrong place. So we see we've guessed R, and R is in the word, but it's in the wrong place. It's not in the first character, so that was correct. E is in the wrong place. Once again, E is in our guess. So we've got 2 letters, and it's in the wrong place. A is in the correct place. So we've got an A there and an A there, both in index 2. And L is not in the answer, M is not in the answer. So can you understand what we're doing there? Any questions about how we came up with that code? So I'll just tell you a little bit about how Python code works. Python is different to other languages by it uses indentation for showing what's in a code block. So all of this code here has been indented from the original for loop, and so all of that is going to be included in the loop. And if we wanted a line after that that was not in the loop, then we would not have any indentation on it. And you can see what the commands that are going to precede a code block all have a colon at the end of the command. So for example, this if statement, it checks, it runs all the following lines in the code block. We've only got one, but there could be several, and they're indented. And then the indentation is removed for the following line that is part of, well, in this case it's part of the if statement, but any lines with this indentation are part of the loop, but not part of any of these 3 conditions. Now I've given you an answer here. This answer is looking at a slightly different way of doing it. It looked at this and goes print I, LG, that's in every single line. So it put that out the front, and so we just had to do the bit that's different in each of the 3 conditions. In fact, I've stepped ahead. The question here was just guess, given an answer and a guess, display which letters are in the right place. So it's not even looking for the wrong places. So I've jumped ahead. In this case, we're just looking for, is the answer the same? In which case it's letters in the correct place is not the correct letter for this place. For my print statement, I've used, I've said end equals space, and what that does is it prints but doesn't give a new line at the end of the line. So normally end is equals a new line. In this case I want to print but stay on the same line, and so these print statements happen on the same line. So if we run that, we get R is not the correct letter for this place, E is not the correct letter. So in fact, in this case, A is the correct letter in the correct place. So that's the only one that's the correct letter in the correct place. Okay, challenge 2, which I've probably already done for you. Find which letters are correct but are in the wrong place. Assume no doubles. So I've got the answer, but we've seen the answer that I've just shown it, but try to work it out again. This I should show you in this enumerate. This enumerate in the solution here is a handy way if you want the index and you want the letters, then you can use enumerate, and then you can put two variable names here before the in, and it will give you both the index and the letter, and then you only need to use guess I to get the letter for the guess, because we've already got the answer letter in each place. Alright, so let's see if we can do really our previous answer with using enumerate, and so we need fewer lines and fewer lines of code. All right, let's go. So for I, remember we had in range, but this time we'll do, and I'll just do shorter variable names, LA in enumerate. So enumerate works on anything that's iterable, so strings are iterable, and lists and tuples, they're iterable as well. Not having much luck with their autocomplete. Yep, that worked. So that prints without a new line at the end. And now we do our if statement, and we're going to have if, else if, and else. So I really encourage you to have a go at these and see how much you understand by typing this in yourself. It really helps to learn this stuff by typing it in yourself. So I go correct letter, correct place. And can you remember how we checked for if it was in the wrong place? We used in, and that just says, is this letter anywhere in the string? And once again, so in works on something that's iterable, so we could have done it in a list, and we're doing it on a string. And it can be any character in the string. So that's the correct letter, wrong place. And the final condition is wrong letter. And that's the answers that we got. Let's have a look at the solution. It's pretty similar. Oh, okay, so the solution, we're going to do this in a function. So we defined a function, and the function takes two parameters, the answer and the guess, and then it loops through all the letters in the guess. What did I loop through? I looped through the answer. But anyway, this one's looping through the guess, and doing the same. Pretty much the rest of it's the same. And now to call a function, so this defines a function. So once again, defining a function starts a code block, because we've got a colon at the end of this code. So all of this code is indented, and then this line here is not indented, so that's outside of the function. So when you define a function, it creates a function, but it doesn't actually run it. To run the function, you have to call it. So to call it, you use the function name. In this one was show clues, no doubles. You have to pass in arguments. In this case, we're passing in the answer and the guess, and they get given different names here. And this is one of the reasons I used the answer and the guess for our global variables out here, so that and in the function I use answer and guess, so there's no mistaking whether something's a local variable inside the function or it's a global variable for the whole script. So I could have done this without any function, without any parameters, and just use global variables, but that's pretty much bad form. When you're writing functions, it's better to use local variables because they become a lot more portable, and you can really compartmentalize the code, and it reduces the number of errors that you get. Alright, so let's run this. R, correct letter, wrong place, correct letter, wrong place, correct letter, correct place, not correct letter for this place. Well, in fact, that last one should be just wrong letter. I should change this to say wrong letter. So this worked really well for when there was no doubles in the answer. So how well does our solution cope with double letters? Now, fortunately, because it's been we've defined it in a function, we can just call the function here with our new guess and answer and see how it works. So the guess is lulls and the answer is Sully. So we've got L is the correct letter in the wrong place, U is correct letter in the correct place, L, L. Alright, so if we were actually playing the game on the New York Times website, we've guessed these three letters and they would all be correct. So then it would say our S was in the wrong place, but this L here would say, well, there's no L's left over, so it's actually just not a correct letter, rather than what we're saying, which is the correct letter in the wrong place. So we've got some problem in our logic here. And so we have to think about what we would do to overcome this bug that we've got in our code. Alright, so we'll say it's not working because the first L in lulls is the wrong letter because all the L's have already been guessed. And let's also, we'll abbreviate our terminology. So we've been using these long sentences. Let's just change them to correct to being correct letter in the correct place, move if we want to, if the letter's correct it has to be moved somewhere else, and wrong if it's just an incorrect letter. And that'll help for other things as well. Alright, now I haven't set this one as a challenge. I've just written a function here, and so we'll see if we can understand what the function does. So what we're going to do is we'll get the answer as a string, and we'll convert it into a list. And we can convert using the list function here. Most data types, you just use the data type with call it as a function, and that will convert whatever value you've got into that function. So list answer will just be split all the letters. Each element of list answer will be a single letter that came from the original answer. Now we're going to create another list, and that's going to be the clues. So the clues are going to be correct, move, or wrong. Now, but we'll start off with the clues. We want 5 clues for the 5 letters, and we'll just start off with an empty string for each of them. So we've created a list, so that a single element list times 5 will give you a 5-element list. And then we'll run through working out the clues. So the first thing we're going to do, the first pass through, is looking for exact matches. Now you can see what we're trying to do. We need to remove all the exact matches out of the guesses and answers, so that then when we're looking at the remaining ones, we can see if those letters are just in the wrong place, because otherwise it's going to look at the letters that we've already guessed and say and get a match for them. Alright, so once we've gone through here and we can remove the letter from that position in the list of answers, but we don't want to just delete it because we want it to otherwise then it would make the index wrong for all the following letters in the list answer. So what we'll do is we'll assign it to a value of none. So we could have assigned it to anything except one of the letters that are likely to be guessed. But none's a good one. None is a value, which means there is no value. Okay, now the second pass here, this is when we're working out whether something is the letter is just actually in the wrong place. So our first condition, if list clue I equals an empty string, that means we haven't assigned it to correct. So we're only looking at the ones where it's not correct. And then we can check to see if the letter that we're looking at in our guess is in the list of answer letters which are still remaining after the others have been removed. And if it is, then we'll assign our clue as move, and if it's not, we'll give it the answer wrong. Alright, and our function is called show clues. So the last part of the function is to display the results. Okay, Leo said we could write a test, and Leo is an expert of tests, so maybe he can write a test for us, and then we'll have a look at how that works. Okay, so let's show the clues. Run this function show clues, and we go L is wrong, U, L, L are correct, and S needs to be moved. So that's correct, and that's what our test could have been. Is for that answer and that guess, we needed to get these results displayed. Now that's actually a little bit tricky in a test to see what's been displayed. So what you'd normally do is write your function in that it returns the clues, and then you can display them how you want. And that would then make it easier to write a test on it. So challenge 3 is in fact just that. Create a function clues which returns the list of clues. Rather than displaying them, we want to return them as a list. And we're going to use constants. So these are global constants. They can be defined outside the function, and the convention is generally if you're writing a constant, you use uppercase characters. If you're defining a variable, then you use lowercase characters. They're really all just variables, so there's nothing stopping you reassigning a value to a constant, but it really helps the programmer to know that this is a value that really shouldn't be changed. Okay, so we'll work through this solution. If you want, you can pause the video and have a go at doing this yourself. But if you prefer just to watch me solve the problem, then you can do that. So we'll get our function. We're going to call it clues. So we'll rename it here. And we're going to use constants here. So rather than using the string correct, we can change that. And the string move, we'll change that to use the constant move. And the string wrong, we'll change that to use the constant wrong. And then at the end of our function, we'll just return that list of clues. Okay, so now we're out of the function. Anything else should be anything else has to have the indentation removed. Okay, so that was pretty simple. And what are we going to do? We just return. We can try, you know, in essence, that's all we needed to do. That answers the solution. That's the solution to the problem. But if we look at the actual solution provided here, you'll see that we then run some code to check what that the answer and the guess came out right. So let's run the solution, because I think everything else is pretty much the same. And all right, can you work out what I did wrong here? It's a mistake I've already made tonight, is forgetting to run this cell, the cell above. So now that's defined. We'll run. There we go. So that runs the function, calls the function, and then displays the results. Now, if you wanted to, you could put in a test, like you could say test result should be, so it's going to be a list, and we want it to be wrong, correct, move, and then in here we can well, in fact, I think we can just say assert test result equals the clues. Run that, and if it comes up true, then nothing happens. So let's just check that our testing method is working. We'll put something wrong in the test, and we'll see what happens if the test fails. And there we go. It's the assert gave us an assertion error, so there's a test that it got it wrong. So that's a quick test that you can use using the assert command, just to check that everything is as it should be. All right, challenge 4. Use the following terminal color codes to display the matching letters in color and bold. When finished with a color, you need to reset it back to normal text. Okay, so if you want to display on the terminal a character in bold, then you have to send it an escape code followed by a left square bracket 1 and M. And if you want it to be a color, you can send an escape code followed by a square bracket and then one of these numbers, 92M, 35M. And then every character that comes after that will have will be in that color and will be bold. If you want to reset it, then you send the escape code and left square bracket 0M. So let's just assign these into our constant names, and then we can use our constants as also the when we're displaying. Now I'll just explain about how we do an escape code. We're using \033. So if you do backslash and then a 0, it assumes that what's coming after that is going to be an octal number. So octal is base 8. So 33 in base 8 is 3 times 8 plus 3. So that's 24 plus 3. So that's 27 in decimal. So there's other ways we could have done that. We could have used CHR27 as a way of getting the escape character using a decimal code. We could have also used hexadecimal codes, which is \x in a string, followed by, in this case, 1b. So 1 for 16. So 1 times 16 plus b times 1. And b in hexadecimal is equivalent to 11. So 1 times 16 plus 11 is 27. So that's the other way of getting 27. So let's run this, and our code will display what those three things all evaluate to, and when Python displays those strings, it does them all in hexadecimal, and they're all the same thing. Okay, so what's the question? Use the following to display the matching letters in color and bold. Okay. So we've got an answer, we've got a guess. Okay, so we're going to call our function. Now you see here we've actually redefined our constants, and so those constants we've redefined are global, so they will be used in this function that we've defined up here. Now normally that's not something you would do, but it's educational here, so that's why we're doing it. But normally you just define your constants at the beginning of the program, and you know, technically we've made the change and then we're rerunning the program, so we're not making the change while the program is running. Okay, so we'll get the results. Clues equals, let's call it the clues. Good idea, because the function name is clues. For the answer and the guess. Okay, and then we want to loop through each of those clues, and we want to loop through all the answers, the letters in the guess at the same time. So let's enumerate, and we'll get our letter L, letter guess, I'll call it LG for guess, and remember enumerate the guess, and we're going to print the letter. So we're going to print the clue first. So the clues and I, and then we're going to print the letter LG, and then we're going to print the reset code. So I'll just say reset, but we don't want a new line at the end of each line when we do the print statement. So we'll say end equals that'll do. And after we've printed all of them, so outside the for loop, we'll just print a new line. So I make sure the second print is not indented, and so it only runs once the for loop has completed. So there we go. We're printing the code to make it green, then we're printing the letter G, and then we're printing reset. And then the next time we're printing the code to make it U, the code for nothing, which is wrong. Then we're printing the U, and then we're printing reset. Then the code for move, which is magenta, and that's going to be in the wrong place as the E. But we've got lots of spaces there, and that's because I used commas in this print statement. And when you commas, the separator between each of the letters, or each of the values that you're printing, is going to be a space. So we can modify the print statement to also have nothing between those. There we go, guess. Alright, so let's have a look at the solution. So the solution is defining a function. So the function wants to return a string which has got all the clue codes in there, as well as the guess, rather than just displaying. Yep, I was just doing display. So we're taking all the letters in the word, and we're taking all the clues, that have come in the list. So, and we're going to look at all the letters in this string and all the elements in this list. Now here we're going to use the built-in function zip, and what that does is it takes each value one at a time and makes a pair out of them. So I'll just print it, we'll just run it to make sure it works. Yep, that works. And now we'll have a look at how zip works. So I'll create a few extra cells in there. So if I've got, let's say I've got two words, we'll say W1 equals ABC, and W2 equals, and we'll do this one in capitals, ABC. And then if I zip those two up, so think about what a zip does. A zip, it takes the teeth of the zip and it alternates between the left side and the right side all the way up. Okay, and that's an iterable, a zip. So let's put that into a list so we can actually see what it looks like. There we go. So it's taken the first letter of each one and put them into a pair, a tuple pair. Then it's taken the second letter of each one and put that into a tuple pair, and the third letter and put them into a tuple pair. And so in my case up here, guess is the first word and clues is a list. So let's do this one as a list. I'll just do this to convert a string to a list, and then I'll print what W looks like, so W2 looks like, so that we can see it. And I'll do W1 as well. So W1 is the string ABC, W2 is the list, capital A in one element, capital B in another element, capital C in another element, and then they get zipped together to make all these pairs. So what I'm doing is I'm creating a list of pairs, and when you've got a list of pairs, then you can use and you're iterating across them, and they're like tuples, then you can put two variables here. If these had three values in them, I can put three variables here, and each time through the loop, each one takes each of the value out of the pair. So letter will take these first values out of the pair, clue will take these second values out of the pair. So is this making sense? Has anyone got any questions about this? Can they see maybe a place in the code that they've been writing where they use zip or enumerate or lists? Anyway, so once we've got this list, once we've got these variables in a loop, then we can append them onto a list, and we'll put a string each one. We'll have the clue, which is that code, the color code, and the letter, and then the reset, and then we'll end up with a list of all of those, and then we can join them all up with no space between them. So we use the string function .join, and it puts every element of the list together as a string, and it between each of those strings it puts the empty string, and that gives us the final string. Now if we look at that, that's actually a code for that could be used using list comprehension. So if you really like to get your reduce the amount of code that you're using, then we can do this using list comprehension. So let's rewrite this function using list comprehension. So the first thing we do is we put in our list what we want to each element to be. Then we put in our for loop. And that creates a list. So let's define that, and we'll run this just to check that it works. Yep, so that's still working. Color clues is now defined this way, so we've got it down from 4 lines to 2 lines. And really, you can, if you like to get really obtuse, you can, we don't even need to create the variable list. We'll just put it all in as a parameter to the function join. And so now we've defined our function in one line. Now, you might decide that that's a little bit too much happening in that one line to understand what's going on. So sometimes it's actually better to write it out in full. But there's also, if you get lots and lots of lines of code, it's nice to be able to reduce these simple lines down to a single line, and means there's less lines of code you have to read. Okay, challenge 5. Use the input and a prompt function to read a guess from the user and display the result. Okay, so let's say guess equals input enter word, and then we can print the result, which is color clues based on the answer and our guess. So when we run this code, you can see it actually pauses halfway through the code. We've got the green arrow here saying that we're on line 1. We've got the play button here just going round and round, and so it's often useful if you notice in Google Colab that things aren't happening. Look for one of these input boxes, and if there are, then there's something that you've got to type in. So let's type in an answer, and it's printed out the result saying, well, that's the S is in the wrong place, the E is in the wrong place, and the TAR are no good at all. So let's have a look at our solution here. Very similar. Probably did a bit more formatting. So let's try grass. And so with solution 5, we're actually lining up the letters, and so you can see which ones are correct. Okay, keep reading user input until they guess the answer. Okay, so we'll say G equals none. Why does it do that? While G does not equal the answer. And then we just want to do these 2 lines of code. We've got a colon here, so we should indent the next block. And let's just use G. So it's asking for a guess here. So let's put in a guess. So the E and the S are correct. Put in another guess. Oh, we got it right. So that's our little wordle game. Let's have a look at the solution that we've got here. So the solution is also checking for the number of guesses that have happened, and so you've got a maximum of 6 guesses. And so it tells you a number for each of your guesses. So all right, we've got 2 letters correct, and of course we know, well, let's just keep guessing rubbish. And I found a bug. It's I put in a 6-letter word, and so of course it can't. Didn't like that at all. So probably worth putting some error checking on your input. Let's try running it again. There we go. And so got to guess 1. But if you went to 6, it would just drop out without saying anything. So next month's challenge, we're going to restrict the guesses to actual 5-letter words rather than a random selection of letters. And that's the code that I've worked out for that. Uses a feature of Python 3.8 called the walrus operator. So I recommend that you install Python if you want to do so for next month, which will be the 12th of April, I think, when we'll continue on this. So install Python either from python.org or Anaconda. Last week we had a look at how to install Python. Let's have a quick look at what an integrated development environment looks like. So Python comes with an IDE called Idle, which is sort of a cross between IDE for integrated development environment and Eric Idle, who is a member of the Monty Python crew. Anaconda comes with an IDE called Spider, which is still a very primitive IDE. The Pycharm Community Edition, that's probably the most advanced one of the free IDEs that I've seen. Visual Studio Code's a bit more lightweight than Pycharm, but can actually be used with extensions in other languages as well. So I'd recommend going to Pycharm and download this one. So when you download it, you'll see there's a professional and a community edition. So grab the community one and install it. And when it installs, it actually includes a Java version. It runs on Java because it's based on IntelliJ, which is their IntelliJ idea is their Java IDE, but this one is for Python. So I'll show you what it looks like. I've got it installed on my computer. I haven't seen any questions coming through yet, but we're going to finish in a couple of minutes. So if you've got any questions, please ask them. And if you can't think of your questions before we finish, then you can still ask them on Slack, and maybe someone will be watching that and see, and they'll be able to answer it for you. Okay, so here's Pycharm. We get, I've just installed it. We can do a new project. So you give your project a name. So I'll call it Beginners Python and Machine Learning 137. You can even create a script that it will run. Now it uses these virtual environments, and this is one of the things I really like about Pycharm. It's a really good habit to get into, is using these virtual environments. If you're just using standard libraries, as we've done today, it's, I guess, not a big deal. But as soon as you start having to install third-party libraries, you don't want your third-party libraries that you're installing for one project to interfere with how another project runs. And it makes it really easy to install once you've written a program and packaged it up into a wheel that can be installed somewhere else. Then if it's got all the requirements configured into that wheel, then those third-party libraries will get installed at the same time as you install the wheel, and it will, if it's going into a virtual environment, then you know you'll have all the correct packages and you won't interfere with anyone else. Alright, so click on New Virtual Environment. If you're using Anaconda, then make sure you check Anaconda here. I use either virtualenv or Conda. I'm not sure of the advantages of using pipenv. I think that's for people who use pipenv when they're creating virtual environments. Okay, so let's create a project and see how it runs. So this is based on Python 3.10, which I've got installed, and it shows you a few things. So we can click on the play button here to run the script, and it will run down and what it's done, it's called hi Pycharm. It's called this function here. Now we've got a breakpoint in here. Yes. So Leo's asked, how do you generate a wheel? So generating a wheel, you have to set up your build configuration to do that, and I could really spend a whole session on how to configure a project to be built into a wheel. So maybe I'll do that in a couple of months' time, because that is an interesting thing, and it is a very useful, worthwhile thing to know how to do. So when you're running, you can run in run mode or you can run in debug mode. And so when you run in debug mode, it'll go all the way up to when it hits a breakpoint, and then in the breakpoint you can see what the values of variables are, and you can single step over your code. So that's, at the moment, the variable name has the value Pycharm. If we step over that, it jumps out. Now we're outside of the function. So this local variable here is out of scope, and so it doesn't exist anymore. So it just gives you a list of all the in-scope variables here. So debugging is a really useful function of these IDEs. Okay, and I'll step over the last step. So that, and now the program's finished, and so it's waiting to be run again. Okay, so that's the session for tonight. I hope you enjoyed it. The next 3 weeks will be a run teaching machine learning functions, and then I'll do the first week of every month. We do a session for absolute beginners, and so I'll be doing that. And but really, we are aiming at beginners every session. We'll just be following more advanced concepts on the other weeks of the month. But you can still ask the absolute beginner questions in any week that you're watching. So I hope you've enjoyed the show, and I'll see you next time.